Today we'll start chapter 9. Chapter 9 is where, we balance these equations and we did these conversions from moles to grams and things like that. Now we're going to take all this and tie it all together, and we're going to do something called stoichiometry. And stoichiometry is doing calculations from the equations. In other words, if I have to produce so much product, how much reactants do I start with? And you can see here, I think this is supposed to be a pharmacist. In industry, they use stoichiometry all the time, because if you're going to have an equation that produces a product, you need to know how much of your reactants. You don't just pour a whole bunch of stuff together, because that can be wasting money. And of course, in industry, you don't want to waste money. So stoichiometry is where you really get into the where all this other stuff kind of starts to make sense. Okay. All right. Just to review, remember, a molar mass is what a compound weighs. It's all the elements and how much of each element and all that. If it's an element, it's the atomic mass. If it's a compound, it's the atomic mass units, that kind of stuff. And then we talked about a mole. A mole is a unit. Whatever a mole is, as far as mass, is whatever it is from the periodic table. And if it's in a compound, it's when you add them all together. And then we also talked about Avogadro's number, the number of atoms or molecules. And then we can use molar mass as grams of a substance over moles. That is something that we'll use quite a bit in this, because we have to convert a lot of times from grams to moles. And then we're going to convert to moles of other substances by using balance equations. And then if we have to switch it back to grams. So when we're doing these problems, basically we're doing conversion factors, but more than just one, usually three. And again, I'll show you how that all works. Okay. We don't really do Avogadro's number much in this chapter, because really you're not going to measure out atoms. That would be kind of crazy. All right, so stoichiometry is the number one thing that you have to do stoichiometry is a balanced equation. If you don't have a balanced equation, you cannot do these problems, okay? The reason why is we're going to convert from moles of one substance to moles of another. And the way we do that is through a balanced equation. We use those coefficients that we use to balance that equation. And if you don't have a balanced equation, you can't do that, okay? So what stoichiometry is the part of chemistry that deals with relationships, quantified, numbers between what you start with, your reactants, and what you end up with, your product. And again, a simple example of stoichiometry is if I'm making a ham sandwich, okay, my reactants would be bread and ham, and then my product would be the sandwich. Well, if my recipe is 2 pieces of bread for 1 piece of sandwich, one piece of ham, excuse me. I need to make sure that if I have 20 pieces of bread, I have 10 pieces of ham. And then I'm going to make 10 ham sandwiches, okay? But if I only have, if I have 8 pieces of ham and I have 20 pieces of bread, now I'm only making 8 ham sandwiches, okay? I'll have leftover bread. And that would be my limited, what I run out of first would be my ham. So if I want to make more ham sandwiches, getting more bread isn't going to help. I need more ham. That's what stoichiometry kind of is. Okay. So if I have a balanced equation, A, B, C, and D are my coefficients. If I have so many grams of A and I want to know how many grams of C I'm going to form, I can use, what I'll do is I'll have A here, I'll put A on the bottom and C on top. And I'm talking about the numbers, the coefficients. Those are from the balance equation, and they determine your moles of each. And then when we use them, it's called the mole ratio. Okay. So stoichiometry problems required a balance equation. Always. If you don't have a balance equation, you can't do it. And then our conversion units. We use our balance equation to convert from moles of one substance to moles of another. And it's called a mole ratio. And it's the ratio of this to this or this to this, whatever you're trying to find. Okay. So mole ratio is a conversion factor. Again, it's just like multiplying by 1. It's between any 2 species, it can be a product and reactant, it can be both reactants, it can be both products. It doesn't, it depends on what you're looking for. But again, it's the ratio between them, and the numbers come from the balanced equation. They're the coefficients. Okay. So if I had this one, I have all kinds of mole ratios. I have 2 moles of this to 1 mole of this. I have 2 moles of this to 2 moles of this. I have 1 mole of this to 2 moles of this. I have 2 moles of this to 1 mole of this. Those are all kinds of, you can have, here it says 6. So it'd be this to this, this to this, this to this, this to this, and this to this. So you have all kinds of ratios that can exist. Again, and it's just the numbers in front. Those are your mole ratios, okay? So again, no balanced equation, you cannot solve stoichiometry problems. And then they have all of them, what I already talked about. Okay, those are all the possible ratios that it can exist from that simple equation. Okay, so mole ratio is used to convert factors between moles of one substance and moles of another. If you start with grams, the first thing you're going to have to do is change it to moles, which we've done a bunch of times, so it shouldn't be a problem. But you need to have moles of the substance you start with, and then you can find moles of the substance you're trying to find just by using your balance equation. Okay. All right, so here I got a balance equation. If 4 moles of oxygen are present, how many moles of water can be formed? So if I start with 4 moles of this, how many moles of this? So the first thing I'd write down is my 4 moles of oxygen. I know that, okay? Now I use my balance equation. I'm going to put moles of what I'm trying to get rid of on the bottom, oxygen, and moles what I'm trying to find, water, on top. And then here I have a 2, and here I don't have anything, so that would be a 1. So that would be my mole ratio, okay? And this comes from my balanced equation. So you put your moles of what you're trying to get rid of on the bottom, moles of what you're trying to find, in this case it says water, put that on top. Then look at your equation. You got a 2 there, and you got a 1 there. Okay, and so then all you have to do is go 4 times 2 is 8, divided by 1. You don't have to divide by 1, but so it'd be 8. So when I have 4 moles of oxygen, I can produce 8 moles of water. That's what I figured out from this equation. Remember, this mole ratio comes from the balancing equation, and this is the only time you use your balanced equation right here, okay? All right, given a balanced equation, write the mole ratio. Okay, so moles of water produced from 3 moles of CO2. So again, we have a balanced equation. So we want to, on the first one, write down what we know. We have 3 moles of CO2, and we're trying to find H2O. So times, and on the bottom we put moles of CO2, on the top we put moles of water. On the CO2, there's nothing here, so we'd write 1. For the water, we'd put a 2. Okay, and again, these are the coefficients. What I'm trying to get rid of on the bottom, what I'm trying to find on top. Okay, and now moles of CO2 cancel out, moles of H2O are left over, and the question said, how many moles of H2O? So I'd take 3 times 2, and I'd get 6. Okay. Okay, here the moles of H2 needed to produce 3 moles of H2O. I suppose that'll be on the next one. So for B, write down what you know. I got 3 moles of water. Okay, and now my mole ratio, I'm going to put water on the bottom and H2 on top. Okay, again, what I'm trying to get rid of on the bottom, what I'm trying to find on the top. These numbers, well, there's the 2 for water, and there's the 4 for hydrogen. So 3 times 4, 12, divided by 2 is 6. That's my mole ratio. That comes from my balanced equation. Okay? So when you're doing mole ratios, write down what you know, then put that on the bottom, what you're trying to find on top, and these are your coefficients from your balanced equations. Okay? All right. Given a balanced equation, again, this is great. We've got our balanced equation. What is the mole ratio needed to calculate the following? We got 4.5 moles of oxygen. Okay, so we're starting with oxygen, and we're trying to find KCl. Again, write down what you know. Oh, there's all kinds of, don't worry about that part. Okay, this is what I'm worried about. I know these PowerPoints come from the book, and sometimes they're a little bit, give you a little bit too much. Okay, 4.5 moles oxygen. Okay, that's what I know I have. Then I got to do my equation, my mole ratio. Okay, moles of oxygen, what I'm trying to get rid of on the bottom, and I'm trying to find KCl, so I put it on the top. Okay, so this has a 2 in front of it, and this has a 3 in front of it. So 4.5 times 2, that would be 9, divided by 3 would be 3. Okay, that's how you do mole ratios. It's very simple. Write down what you know, what you have, put that on the bottom, what you're trying to find on top, and then these come from your balanced equation. That's why you have to have a balanced equation to do these problems. Okay, make sure you have a balanced equation. If you don't have it, and look at your equation. Sometimes I'll just write an equation and it's not balanced. It has to be balanced. Okay, we can also convert substances from moles to grams, which we actually need to do most of the time. Because if you're in the lab, we have scales. We have electronic scales that will measure mass. We don't have mole meters. So really the only time we tend to use moles as a finished thing is like with gases. But honestly, it's easier to switch it to grams because that we can measure. Okay, so sometimes we have to do another step. Sometimes we have to use our mole ratio and then switch them to grams, or sometimes we start with grams and we have to switch them to moles. Because you can't use the mole ratio until you have whatever your reactant or your product in moles. So if it starts with grams, the first step you do is change it to moles. That's really simple. It's like we did before. 1 mole on top, it's formula mass on the bottom, and then divide. Okay? So, and then if you have to convert it to moles, if your answer is in moles, you're done. If it needs it to be in grams, then you switch it like we did before. Okay? 1 mole on top, or 1 mole on the bottom, whatever its mass is on top, and then you multiply. Okay? So again, if I have moles, let's say on that one, I had 3 moles of oxygen, and I need it in grams. Okay? So I'd put 3 moles here, 1 mole, and oxygen is O2, so the mass of O2, 16, but there's 2 of them, so I'd put 32 up here, and then I just multiply. Again, it's the same kind of conversions we did before. Now we're just stringing them together. We're putting all the stuff that we did before, and now we're putting it together, and now it really has more function. Okay, before sometimes the stuff we do, you're like, yeah, what? Why am I doing this? Well, now we have a purpose. Okay, so, and honestly, when you're doing stoichiometry, you can change it to molecules, but we don't do that a lot in stoichiometry because I can't measure out molecules. I know 1 mole has that many molecules, Avogadro's number, but as far as counting and all that, that wouldn't happen. Okay, here's a flow chart, and this is in your book as well. Sorry, this says atoms/molecules of desired, but this is a flow chart. Usually you start with grams of known, and you switch it to moles, and then after you're done with that, you can switch it back. But again, the big thing to remember about stoichiometry is you need a balanced equation because you need that mole ratio. The mole ratio is what converts it from one substance to another, a reactant to a product, or a product to a reactant, or a reactant to the other reactant. They do these sometimes. You want to know exactly how much stuff of each you need, like with the bread and the ham. I know that I need 20, if I have 20 pieces of bread, I need 10 pieces of ham. That's a simple one to do. You can do the same thing with stoichiometry, but you know, with numbers, you're not necessarily as simple as bread and ham. Okay. Okay, so here's a, where are we at? We've got a couple minutes left here. Okay, a known substance is given in moles, and we want to find another one. Okay, here's my balanced equation. All right, how many moles of carbon dioxide will be produced, by the reaction of 2 moles of glucose? This is glucose. So write down what you know. And again, don't worry about all this, just go down to here. Write down 2 moles of glucose. Okay, now I want glucose on the bottom, and I want what I'm trying to find, carbon dioxide on top, so I'm going to use this mole ratio. Because if you look, moles of glucose cancel out, moles of carbon dioxide are what's left, and that's what I'm looking for. And then these numbers, there's a 6 and there's a 1. They come from my balanced equation. So 2 times 6 would be 12. So when I have 2 moles of glucose, I will produce 12 moles of carbon dioxide. Okay? That's how you do a mole-mole calculation. Write down what you know. Use your mole ratio from your balanced equation, what you're trying to get rid of on the bottom, what you're trying to find on top, and these are your coefficients. Okay, on this one, we'll do this. Oh yeah, this will be the last one we get it. Okay, how many moles of aluminum are produced by 0.5 moles of oxygen? Here's our balanced equation, 0.5 moles of oxygen. Okay, put moles of oxygen on the bottom, and I'm trying to find aluminum on top. I go to my balanced equation, there's a 4 here, and there's a 3 here. Okay, so 0.5 times 4 divided by 3. And you get 0.67 moles. Okay, so that's mole to mole calculations. That's what we're going to do first. We're going to expand on these and do some more complicated, but we'll start out simple. So this is the end of the notes today because I'm just about out of time. So we'll pick up with more calculations on the next part of the chapter.